Welcome to Unit 1, Relations and Functions, Section 3, Sinusoidal Functions. This would be in Chapter 8 of your textbook. At the conclusion of this chapter, you will be able to develop algebraic and graphical reasoning through the study of relations. You'll be able to represent data using sinusoidal functions to solve problems. Sinusoidal refers to trigonometry involving sine and cosine. This section will focus mainly on the relationship between sinusoidal equations and their corresponding graphs or functions. New terminology will be defined, such as amplitude, period, and midline. Problem solving will involve the development and application of trigonometric equations for real-life scenarios. Here's your checklist. Understanding angles, and again, each part will have notes and practice. Exploring graphs of periodic functions, graphs of sinusoidal functions, the equations of a sinusoidal function, and modeling data with sinusoidal functions. Also, for assessments, you have the sinusoidal function review, which is formative, the curriculum review, which is your open book summative, the quiz, which is your closed book summative, and in this section, because there's only one chapter in it, has the final summative unit assessment. Okay, awesome. Let's take a look at what these guys have to offer. Part 1, Understanding Angles. First of all, you need to know what an angle in standard position is. Angles are made up of two arms. One is called the initial arm, and it's found on the positive x-axis. The other is called the terminal arm, terminal meaning where the graph ends. Okay? Now, for it to be in standard position, not only does the initial arm have to be on the positive x-axis, but where the two meet must, also known as the vertex, must be on the origin of the graph. So here at 0, 0. Okay? Now, angles are measured from initial to terminal. So if you can see the purple arrow here, it's going from the initial arm to the terminal arm. Okay, so then if we say that the initial arm is 0 degrees, okay, then my angle, of course, would be going from here to here. So this would make this 90 degrees. And over here would be 180. And at the bottom, 270. And once you've completed back to the initial arm, we've gone a full 360 degrees. Now, notice that I'm moving in a counterclockwise direction. That produces positive angles. However, if I were to take my terminal arm and start here and move this way, that would produce a negative angle. So clockwise motion is a negative and counterclockwise is a positive. Okay? Now, if you notice then when I got to here, that was a full circle at 360 degrees. But actually, I can just keep going forever and ever. Okay? Each time I do a full circle, that's a multiple of 360. So one full circle is 360. Okay? Two circles would be twice as much, or 720. Okay, and so on and so forth. Okay? And I can do parts of circles as well. So I could draw, as the example shows you, an angle that's 500 degrees, which of course is one full circle and another 140 degrees. The same is true for a negative angle. Again, negative, so going clockwise for 360 and then another 140 degrees. Okay? So notice, of course, that my terminal arm is in quadrant 2 here, but in quadrant 3 here. Okay? Now, we don't just have to use degrees to measure angles anymore. There are other things that angles can be measured in, such as radians, gradients, and revolutions. The unit used depends on the situation. As far as you folks are concerned, radians will only be used in addition to degrees. So, what is a radian? Grab a piece of string or dental floss or some pipe cleaner or something, and what I want you to do is I want you to take it and lay it on the radius, okay, and make sure it's that length. Then what I want you to do is take that string and curve it so that same length is here on the circumference of the circle, okay? And then I want you to draw this. Now, because this is a radius and this is a radius, those are the same length, and you also made this piece the same as those, so this is the same length as the other two. Okay, the angle produced here at the center is a measure of 1 radian. Okay, so theta equals 1 radian. Okay, now I want you to take the string and flip it, so now we have it like this. Okay, so that makes 2 parts of the circumference, and I want you to do it again. Okay, and then that becomes 3 parts of the circumference, 3 and a little tiny bit. So remember that this was 0 degrees, and this over here is 180 degrees. So 180 degrees is the same as how many radians? 1, 2, 3 and a bit. Boy, what number sounds an awful lot like 3.14 perhaps? Oh, 180 degrees is the same thing as pi in radians, so pi radians. So 3.14, etc. Okay? All right, cool. And again, if you were to continue going, so there's another one, and another one, and another one, and another little bit. So then that means 360 degrees has to be, well, if this is 1 pi to get to here, from here, then this has to be another one, or 2 pi radians. Okay, so approximately 3.14 radians to get from here to here, or 6.28 or 2 pi radians to get 1 full circle. Okay, so again, just some reminders what central angle is, and again, each of these lengths is the same one. So they all measure the same as the radius. So a radian is the measure of the central angle bounded on all 3 sides by a length equivalent to the radius. As seen in the demo, 180 degrees is the same as 3.14 or pi radians, meaning that 360, as we looked at the last page, that's the same as 2 pi radians. This relationship can be used to convert any angle from degrees to radians and vice versa. Radians are not written with a unit symbol, i.e. 2 pi does not have radians usually written after it, like 360 degrees has a degree symbol. Okay, so no units on radians. That's how you're going to be able to tell the difference between radians and degrees. So if you'll notice in example 1, all of these guys have degree signs, so we know they're in degrees and you're going to convert them into radians. However, in part 2, every single one of these examples, okay, none of them have units after them, so you know that they have to be in radians and you're going to convert them into degrees. Okay, so let's go. Convert into radians. So I'm always going to use the relationship that pi is the same as 180 degrees. So where should I put the 90 degrees? Well, they should go on the same level as the other degrees, so that would be on the bottom here. Okay, how am I going to find x, the number of radians 90 degrees makes? Well, I'm going to cross multiply. So x is equal to 90 times pi divided by 180. Now, as we know, don't worry about the pi because remember pi is an irrational number. So we're just going to use the pi symbol to hold its place. Okay, 90 divided by 180, well, 90 is half of 180, so that's the same thing as 1/2 pi, or pi divided by 2, because 90 goes into 90 once and into 180 2 times, so pi over 2. Now, it does say convert to the nearest hundredth of a radian. You only have to worry about that if it can't be, if there's no pi involved, okay? If you have a pi, then you can definitely just leave it in pi notation. Okay, let's go to the next one, 300 degrees. So again, I'm going to start with pi over 180 equals x over 300. Okay, because again, degrees should be on the same level. We're going to cross multiply. So x is 300 pi divided by 180. Okay, and as you know, you can simplify because they're both divisible by 60. So 60 goes into 300 5 times, and 60 goes into 180 3 times. So x is equal to 5 pi over 3. Good. And again, you don't have to simplify because it's in pi notation. Okay, let's do part C. Start again. Pi is 180. And again, 495 goes on the same level as 180. And that's x. So x equals 140 or 495 times pi divided by 180. Okay? And of course, we can simplify that fraction by dividing them by 45, I believe. So 45 goes into 495 11 times, and 45 goes into 180 4 times. And again, we don't have to worry about simplifying. You can any further. You can type that into your calculator if you want to make it into an angle or into an angle with decimal places, but you end up having to round. 11 pi over 4 is exact, so it's lovely. Leave it alone. All right. Next one, convert to degrees. Round to the nearest degree. We're going to do the exact same thing, but just in reverse. So I'm going to say pi over 180. Now, because this is given in radians, it goes on the same level as the pi. So that's 2.5 up there over x. So again, x we're going to cross multiply. So we're going to get 180 times 2.5 divided by pi. And of course, we're going to type that guy in and round to the nearest degree. So you get approximately 143 degrees. Okay? Part B, same thing. Pi over 180 equals 9.25 is in radians, so it goes up with the pi over x. So x is going to equal 180 times 9.25 divided by pi. And that works out to be, to the nearest degree, 530 degrees. Okay? Good. Last but not least, part C. So start again. Pi is 180. Now again, 5 pi over 6 is radians, so that should go with the other pi. All over x. So x is going to equal 180 times 5 pi over 6 divided by pi. Now, if you'll notice, the pi should cancel out because I've got one in the numerator and one in the denominator. 6 divides into 180 30 times, and so I'm left with 30 times 5, which is 150 degrees exactly. Okay, so don't have to worry about rounding in that question. Okay, number 3. Which is greater, 4 radians or 250 degrees? Well, in order to compare them, they have to be in the same units. I'm going to change 250 degrees into radians. I, of course, will start with pi over 180. If you wanted to do 4 radians into degrees, that would also work. Totally up to you. All right. So 250 degrees goes on the same level as 180 because they're both in degrees. And I'm going to cross multiply. So x will equal 250 pi divided by 180. Now you can simplify that, but it's going to be still hard to compare it to 4. So just type 250 times pi divided by 180, and to 2 decimal places, that's 4.36 radians. Okay? So obviously that is greater than 4 radians, so 250 degrees is greater than 4 radians. Okay, so for the practice problems on page 489, you're going to be using this ratio that pi and 180 are equivalent to convert things back and forth from degrees into radians. Make sure you show your teacher when you're finished.